Rahim. Today I'd like to talk about the set notation. This is actually a very important concept that we don't typically emphasize, but it's very helpful as you learn higher level math. You cannot go really much in algebra or calculus without learning the set notation. And you'll see the value of this because we're going to need and use this very much indeed in the next few chapters. So I'd like to actually today just take the time to go over this in some reasonable detail so we have a good, solid working understanding of the set notation. To begin then, I'd like to review a few things. That is the numbers. We have a set of natural numbers, as you remember, which is like this: 1, 2, 3, 4, and quadratic. So this is a set of natural numbers. What I'd like to do today is actually introduce these to you in a more formal manner. So we have a set of natural numbers. We can call that a set of natural numbers like this. Now, all of these sets of numbers are given formal names, and these are not like written in stone, so to speak. When in doubt, you can just spell it out. But they have formal symbols. So when you see some textbooks of higher math, you will see these symbols. So the natural number is typically given this symbol. And in textbooks, you can basically just see it as written as bold N, or also as an example. The set of natural numbers can be written as this. So here, the capital letter N. So you can give the set of numbers names. In mathematics, you can have a set of anything, set of any objects. You can have a set of pencils, and you can have a blue pencil, red pencil like this. So you can have a set of pencils called P. You can name it anything you want. So the P is a set of pencils, and you have how many pencils in there? I have a red color pencil. So I'll just write the colors. Have a red color pencil. I have a black color pencil, and I have a green color pencil. So you can have a set of anything, but you'll observe, as I have demonstrated here, there's a particular notation, typically used capital letters, alphabets, to designate the names of sets. And then you use these curly brackets, right? There are different types of brackets in mathematics. These are popularly known as the curly brackets. So you use curly brackets to denote sets of numbers. For example, you wouldn't write a set of natural numbers starting like parentheses, right? Typically, you won't do that. These are parentheses. So, and you would not use like square brackets. They actually have some specific meaning as well in mathematics. So there are different brackets. These are curly brackets. C-U-R-L-Y, curly, I guess. And then you use a parentheses, and these are called square brackets because I guess if you put them next to each other, they make a square or something like that. So in set notation, you use the curly brackets to denote the beginning and the end of the set. So that same thing here in the case of natural numbers. So I can say the set of natural numbers, N, it is something like this. All right? It is the set of numbers such as 1, and then you just kind of describe the numbers like this. And that'll go, the ellipses here, of course, the dot, 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 the ellipses imply that this pattern will continue. Now, let's say someday you want to talk about a particular number from this set of natural number. And you say, I have a certain number from the set of natural number, and this particular number, arbitrary number I'm talking about. So it's very possible that someday you want to talk about some number that belongs to the set of natural numbers. So instead of like talking about it, when you're defining the set itself, you can say the set N. To let everybody know that in the future, anytime you want to refer to any arbitrary or any particular number in this particular set, you can say you're going to refer to it as N. That is a generic, like a citizen of this set is known as N, any particular citizen. So N could be any representative number from this set. There are other notations that you can important to the same concept. As you can say, the number 3 okay, it belongs to here, is part of this set, right? So you can say 3 belongs to this set. That is absolutely true. Or 3 is an element of this set. So all the components of each individual component of the set is called an element. So 1, 2, 3, etc. is an element, right? E-L-E-M-E-N. So 3 is an element of this set. So you can say 3 is an element of this set of natural numbers like that. That's how you write it. 3. This is not an E. It's kind of like a funky E like this. Okay. So you can say 3 is an element of a natural number, of the set of natural numbers. Isn't it true? So this statement, 3 is an element of the set of natural number, is true. So, and here's if you want to say something is not an element, okay, how about this? -5, is that an element of that? Does it belong to the set of natural? It does not, right? So you can say 5 is not an element of the set of natural numbers like this. Okay? So these are some of the things that we are going to kind of learn in this lesson today. So what I've taught you so far is I've taught you the symbol for the set of natural numbers, which is like this. And I've suggested to you, you typically name sets using capital letters. And when you want, these are reasonably universal symbols. These are not written in stone, but the set of natural numbers typically written like this, and we'll see set of real numbers is written like this. I'm so used to this. If you recall, when I'm sometimes teaching, I'll write this and on the board for real numbers because I've done that since I was your age. So, and I've suggested to you we typically use curly brackets for to denote sets of things. And I've suggested to you this means element of, and then if you wanted to say something is not an element of this, you just say something, you just put a cross across that. Okay? And I've also suggested to you that you can if you wanted to describe a set like this, and then you can name, here we picked the letter N. You could have picked any letter. You could say X or P or whatever, but in this case we picked the letter N to designate the average common citizen of that set, if you wanted to refer to it as a future in the future. Now we're going to talk about here the set of numbers that we're used to, the natural numbers, the whole numbers, the integers and rational numbers, etc. But as I said, that you could have a set of anything. Now all of these are infinite sets. That means there are infinite number of elements in these sets. They don't have to be. I could have a set of K, and I'm defining the set of K like this. This set, and it's a funky curly, you know. So set of K consists of these numbers: square root of 5, pi, and the imaginary number I. Here it is. That's it. This set K only has 3 elements, and I chose these 3 elements because I don't know. I just happened to pick those 3 elements. Right? So this is a finite set, whereas the set of natural number is obviously an infinite set. Okay? So this is a finite set, and this is a infinite set. Now, here, there's another thing that we can say. All right? The concept of a subset. Now I have a set of natural numbers. Now I'm going to pick another set. I'm going to call it the set of, I don't know, I'm going to call it set D. I don't know. Or maybe I'll call it the set S for subset. I have a set, I'm going to call it S. And this set is going to contain the following numbers: 3, 18, and I don't know, 99. All right? Now you understand that this set S, every number here is happen to be a natural number, right? So I can say that the set S, okay, is a subset of the set of natural numbers like this. See? So now look at this. This is a very interesting thing. I have written here S is a subset of the set of natural numbers like this. See how useful, as you can see, this symbolism is already to us. So you can have finite sets and you can have infinite sets, correct? That's another thing that we have learned today. So you can have finite sets, F-I-N-I-T-E, or you can have infinite sets, correct? And then I also taught you the concept, or we reviewed the concept of subsets, right? All right. So natural number set is like this. And then if you recall, we had the following set, the set of whole numbers. Set of whole numbers includes basically all the natural numbers and an extra number, 0, correct? And that was our set of whole numbers. Set of whole numbers is 0, all right, plus all the natural numbers, get there like this. All right, you can call it and give it a name. I don't know. You can call it W here if you wanted to, or you don't have to if you're not going to refer to it. That's a set of whole numbers, right? Then you can say set of natural numbers the natural numbers is a subset of whole numbers, correct? Everything that is contained in the set of natural numbers is contained in that set of whole numbers. Okay. All right. So after this, we had, now there's typically, or you can use W for a set of whole numbers, and after this set of whole numbers we have a set of, what do we have on top of this? So you have 1, 2, 3, this is a set of natural numbers, and then you have 0, 1, 2, 3, that's the set of whole numbers. What do we have outside of this? We have integers, right? We have -3, -2, -1, pen like this, like this. That's a set of integers, correct? Now, I typically just, when I'm writing integers, I typically just write like this, the set of integers like this, int. All right, but there is a symbol given popularly to this, and the symbol that's given to the set of natural numbers of integers actually is this symbol. Oh, we can put it on this side. Capital letter Z. Now, why Z? Apparently, Z is German for numbers. G is German for is Zahlen, apparently, actually. Z-A-H-L-E. Unless Zahlen is Zahlen. I mean, I don't know how to say that in German, but Zahlen means numbers in German. Well, I ain't in Germany, so I don't typically necessarily use that. So you can just say integers or whatever, or you can call it that. Okay. So the set of integers, now the set of integers goes both direction, right? So it's dot 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 comma -3, -2, and -1 and 0, and then 1, 2, 3 dot dot dot, and you can choose a alphabet too here. You can call it P and then like this if you wanted to, whatever. Here we just leave it be. Okay, so that's a set of integers. Okay, then we have a set of rational numbers. Okay, so next is the set of rational numbers. The set of rational numbers, let's call it R over here. Sorry, not like R like that, because this is set of rational numbers. Now, the set of rational numbers is also given a symbol, and the symbol for the set of rational numbers actually is Q, like this. You can like Q like that. So for Q for quotient, see? So Q is for quotient. Because as you know, the set of rational numbers is everything that can be written as a quotient. Now, how do you write that over here? I mean, how do you write all those representative numbers? You can't literally do like 1/2 and then 3/4, because that doesn't cover all the numbers, right? So how do you go about writing the set of rational numbers in this form? Well, the thing is, the way you do it is you actually define the properties of the set. See here, what we did over here in all of these circumstances is we kind of give a sample representative of the set. In other words, we said, okay, this is how the set looks. It's like if there's somebody telling people, showing people a child what cars are like. That's a car, that's a car, that's a car, to teach him what a car is. Or if you can, if the child is mature enough, you can define, see, anything that has 4 wheels and kind of goes on the road is probably a car. So that's like you can define the set of numbers. So it's the same way you can kind of have a descriptive notation. You can call it like illustrative notation. You can describe the set, or you can give a rule for the set. So the set notation can be written as a rule. So the set of rational numbers, you can, if you don't want to use this Q, and I typically many times I don't like to use that Q, I just write the set of rational numbers like this. Set of rational numbers is this, like kind of like that. So, or you can use the Q for the quotient. So you can describe the set and by the rule. So the set of rational numbers is a set of all numbers like this, like P over Q. So, and then you put this slash over here, the straight bar over here, and then you say, and then you describe what P and Q are, where P and Q are integers, okay? Where P and Q are integers, and Q, as you know, it cannot equal to 0, because that's haram. You can't divide by 0, right? So you can write it like that, or you can, in a more elegant fashion, you can say a set of rational numbers, a set of all numbers that can be written as a fraction, P over Q, right? Such that P and Q are elements of the set of integers. You can use the Z, or you can just use the set of integers like this, set of integers. So P and Q are an element of a set of integers, and Q cannot be equal to 0 like this. So this is a more elegant and more beautiful way and of describing the set here, where you you say this is what I'm going to describe, and this is how it's described, and you can do that for in different ways. So this is a set notation for the rational numbers. And then there's a set of irrational numbers, and of course the set of irrational numbers is anything that's not rational, right? Any number that cannot be written as a rational number. And the set of real numbers includes the set of irrational and rational numbers, right? Okay, so this is a set notation. So far I have described to you the following. I have described to you that how we write set notation, and then how you say the certain number is an element of the set notation, right? And we have, let me erase this so I can make some room, because we have some work to do here still. Okay, and so they're finite and infinite sets, right? And we use curly bars. So this is a set of natural numbers and a set of whole numbers, and there's a set of integer or Zale numbers, or you can just say the set of integers like this, and a set of rational numbers, which is the symbol of that is Q, or I just write down the word rational, and you can write down irrational for irrational number, and this is capital R like this is typically written for the set of real numbers, and this is kind of important because we talk about the real numbers a lot. So these are kind of like the symbols that are probably worth knowing. So this is a set of rational numbers, and then after we're running out of space here, so you can just write over here irrational numbers, and then set of real numbers, right, like this. Okay, so we have those. Now and then I told you how we write a descriptive rule for all of these things, right? Okay, now the other thing that I like to do here is use the number line over here to write intervals, all right? So for example, if I have this, so x is greater than -2 and x is less than or equal to 3. Now if you wanted to express this on the number line, you're very familiar with it, right? So here's 0, right? And then you draw that out on the number line. So this is 1, and this is 2, and this is 3, and this is 4. This is -1, -2, -3, -4. And you're comfortable, I hope, of drawing this out. The way you do this is x is greater than -2, okay? And that means you make an open circle at -2, and then it's greater than, so it's going to be this way, and x is less than or equal to 3, and that's a closed circle like this, right? And then you connect these two, and that's the interval. So this is a visual representation. This is a graphical representation of a set, and this is just a algebraic expression of the same thing. Okay, now, and you can write this as a set notation too, all right? So you can say x this is a set of all numbers x such that x is greater than, or you can combine these two, right? So x is greater than -2, x is less than or equal to 3, like this. Here it is. Okay, so this would be written in a set notation. So all numbers x such that this is the way you would read this. The way you would read this is all numbers x. Then this would be read as such that, S-U-C-H, such that that's the rule. Okay, so this is how you write this in set notation. This is how you write an algebraic expression, and this is how you represent the same idea in a graphical version. Now, so let me write this over here. Okay, this is also represents the set of all numbers x such that, okay, x is less than or equal to 3 and x is greater than -2, like this. So that's a set notation for the same graph. Okay, now there's another way of writing the same thing, and this is what I like to talk about next, and that is describing intervals using the interval notations. Okay, so this is a interval. This thing is called an interval on the number line. So there are intervals on the number line. Okay, so the intervals like this one is a bounded interval. That means it's like this. Okay, so on the other hand, if we take this particular example, x is less than or equal to -2, or this has to be or x is greater than or equal to 3. In that case, I have -2 over here, and this 0 over here, and 2, and this is 4. And in this case, the way you would draw this out is x is less than or equal to -2. In this case, it's going to be closed like here, and the arrow is going to go this way, right? And x is greater than or equal to 3 over here, like this. Okay, so in this case, you're describing the x, the set of numbers, like this, right? And if you wanted to write this as a set notation, you could do that too. You could say this x is like this, and you just write down the rules over here. X is less than or equal to -2, or x is greater than or equal to 3 over here. Now this is an or statement, and this is an and statement. That's why you can combine this. You can't combine an or statement. Yes, you cannot combine an or statement. Like, it wouldn't make any sense. If you change this or to an and, there's no x that will satisfy this criteria. It's an empty set, right? So this is an or statement. All right. So this is a graphical representation of the number line. This is a set notation of the same idea. All right, and then there's a third way of describing the same thing, which is what I like to do today, which is one of the reasons I'm actually having this discussion. So these are called intervals, the intervals of numbers on the number line. So this interval over here, okay, so this interval over here, this is called a bounded interval. This is a bounded interval. That is, it starts here and ends here. You know the start and you know the end. Where this interval over here, this is unbounded, right? See this? Unbounded, because it keeps going forever. There's no boundary to it. Okay? So bounded interval, that means those that have boundaries. An unbounded interval. Alright? So this is an unbounded interval. Let's use a different color to just highlight that idea. So this is an unbounded interval. Correct? So bounded interval, there's a clear boundary, and this is an unbounded interval, right? And then the other thing that we need to know before we complete this discussion, and is you can say that this is, of course, an open end, right? This is the open end of this bounded interval, and this is a closed end here, which you're familiar with, right? So this end is open end, this end is closed end. And in this case, even though this interval is kind of unbounded here, it has this end of it is closed, right? Okay. So this is a closed end, but here it goes to infinity. I mean, there's that, it's never going to stop there, right? So the way you describe this is using parentheses and square brackets. So you can intervals. So you use parentheses to represent a open end. So here you can say this interval can be described as this. See, open parentheses -2, and this end is a closed end, so you describe it as 3 like this, and that's a closed end like that. Okay, so this whole thing you can write that as like this. So you can say x is an element of this, x is an element of this interval right here. Okay, this means again that this is an open end. That means 2 is not included in this set. All right, 2 is not included in this set, but 3 is included. So the parentheses represent open end, and the square brackets represent the closed end of the interval. So here you can rewrite this as x is an element of, now here is going to be closed ends on both sides, right? Right? So now x is less than or equal to -2. I'm sorry, let me repeat that. So this one you're going to have to describe in 2 separate notations here, okay? Because this part of it is going to be like this. It's going to be -infinity, like this, all right, all the way up to -2, and that's a closed end, right? And or x is going to be an element of, so x is an element of this -infinity, so because this is -infinity, and this goes all the way up to +infinity. You can't close it infinity, right? So, or you can say x starts out at 3 and includes 3 like this, and it goes all the way up to +infinity like this, and that's the open end because you can't really close the infinity. Correct? So now, so I have described to you several ways of writing the same set. So I like to take this particular last example and write this particular example in all 3 notations that we have talked about. You can simply write describe what x you're talking about, or you can write that as a set notation. A set x is a number, is a set of all numbers like this, where x is like this. X belongs to a set of all numbers x's like that, such that x is less than or equal to -2, or x is greater than or equal to 3. So you can, this is a set notation, or you can write what's called the interval notation, and you can just say an x is an element of this this particular set. So and then x is an element of, you write this set first, right? So that goes from its open end, from coming from -infinity like this. Whoop. I've learned to write infinities like kind of like you draw 2 eyes like this. Yeah, that looks kind of like neat. But before, my infinities used to come kind of funky. So anyways, so here's one and here's the other. Like that looks much more neater. So if you kind of think you're drawing kind of like 2 eyes like that, that kind of, I think, helps in drawing infinity. So it goes from -infinity, but you can't bound it -infinity. So you use the parentheses to indicate open open end, and then it goes all the way up to -2, and that's a closed end. If the 2 was open, right, you would make that parentheses 2, but this means that 2 is included there. Or x is an element of this, or x is an element of now. In this case, the 3 is included on this side, and it goes to +infinity like this, and that's an open end. So these are 3 different ways of describing a set of numbers, right? Descriptions and set notation, and this is the interval notation here, INTERV, interval notation over here. Okay, so this is a visual graphic representation of this as well. This is going to be very useful to us, this concept, and we shall continue to use it until it becomes natural to you, you'll see it's not that difficult, and you'll be very comfortable, and in fact this is a very, very useful notation, you'll see. Until next time, assalatu wassalamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.